Now that we've discussed system hacking in the last chapter, this chapter focuses on yet another way to hack into computer systems and networks, and that's through the use of malware. Now, malware actually is one of the most common ways to attack a system or network, because if you think about it, you've got to get attack tools onto the box, you've got to be able to control the box, get privileges on it, and escalate those privileges, as we discussed in the last chapter. Malware is one venue for that, one way to get entry into the operating systems, the applications, and even the network devices sometimes. Now, we think of malware basically in terms of viruses, but there's actually a pretty exacting breakdown and definition of what malware really is. We have Trojans, viruses, and worms, obviously, and there's some other forms out there as well. And there's also malicious scripts and web-based applets, rogue JavaScripts, for example, or ActiveX controls that have been used for malicious purposes. So you can basically classify anything that's malware that performs undesired actions on the system or causes intentional harm. So we're going to talk about some of these different types of malware throughout this chapter. We're going to cover Trojans, viruses, and talk about the other types of malicious applications out there, malicious scripts and so forth, that can allow a hacker to gain control of a system. Now, one of the biggest problems that hackers have is how do we get the malware on the system in the first place? How do we get a Trojan on the system? Well, there's a wide variety of ways. And you'll find that you could use every trick in your bag of tricks to get malware on a system. You could trick unsuspecting users, and that's probably the major way it happens. You could also embed it in other software, such as what we do with Trojans, download it to the client, to the PC, or whatever without the user's knowledge, and of course infected media like infected CDs and USB sticks. So there's several different ways to get it on there. And really, unless you've got physical access, you're going to have to use one of these methods. You're basically going to have to trick the user into doing it or get them to download something from the internet, from a website or something. Now, hackers use malware for all kinds of purposes. Of course, we use them to invade systems. We may want to steal or alter data like financial data, passwords, and so forth, get these credentials like passwords, or even use malware to conduct attacks on other systems. That's really what botnets and zombies are about, is attacking other systems, typically using remote control software or malware from an attacker. Now, you may think that programming a virus or writing a piece of malware or wrapping a Trojan up is a very complicated matter, but it's actually not. Unfortunately, it does not require any in-depth knowledge of programming. There are simple programs, point-and-click GUI programs that you can click Next on, and it will create and configure and wrap malware up for you. So it's actually very easy to do. Now, how do we get malware delivered to a system? I mentioned a couple of different ways, but let me give you some examples. Unsuspecting users, maybe through tricking them into clicking on something, obviously. Phishing attacks. That's a big source of malware. Not only do phishing attacks enable attackers to get credentials by emailing the victim a false link to click on, and then they click on the link and they put in their credentials. They think they're going to a valid site, but they're really not. Hacker collects the credentials, but you can also send malware down through a phishing attack as well. Cross-site scripting attacks, and we'll talk about those a little bit more when we talk about web hacking. There's also some other web-based scripting attacks we could use to get malware on a system. Infected media, obviously, if you get an infected USB stick or CD-ROM or something like that, or can get it on the hard drive through the network, maybe through a shared file or something that of that nature, you could get it to a system. Malicious websites, some malicious websites have malware on them, and if you click on the wrong thing or you get a pop-up, and it doesn't matter what you click on the pop-up, if you try to close it, you're going to download malware. We can also get malware to a system by embedding it in innocent-looking but useful programs. That's really what a Trojan is. Now, some different malware attacks that we could look at, some different ways that we could use malware against a system. Keystroke logging, obviously, and I'm not talking about just logging passwords and usernames, although that's a popular use for it. I'm talking about logging entire documents of keystrokes. Screen captures, seeing what a user sees on the screen and taking a snapshot of it without them knowing it, sometimes even taking video of their screen without them knowing it. Email snooping, looking at their emails while they're typing them and before they're sent. Chat captures, if they're chatting or using IM across their network, malware can capture that. Taking over an entire system. obviously getting a system to do what you want it to, taking it over, removing files from it, sending files to it, making it change its configuration, making it create accounts, for example, wiping a disk, or possibly even worse, encrypting a disk so the user can't access it. And we'll talk about ransomware a little bit later, but basically that's what you might do with ransomware, is encrypt a disk and then ransom off the key to decrypt it. Webcam activation is a popular one. People have had instances of their webcams being activated by malware. Now, I mentioned data ransom, and basically ransomware is a way to threaten the user with deletion of data or encryption of the data unless they pay some money. Data erasure and theft, obviously, is something that malware can do, password theft, and using malware to attack other machines. That's what a botnet or a zombie is. And finally, you can use malware to create and propagate a distributed denial of service attack against a machine or an entire network. So those are some of the malware topics we'll talk about over the next few sessions when we talk about Trojans and viruses and so forth. We'll go into these a little bit more in depth then. The first type of malware we're going to discuss for this chapter is the Trojan, and Trojan is probably the most popular kind of malware that a hacker will use against a system. Now, Trojans basically are a unique class of malware. They're not like viruses or worms. They get their name from the Trojan horse of Greek mythology. If you remember correctly, from Greek mythology, the opposing army hid troops, in the big wooden horse structure, sent it to their enemy as a quote-unquote gift, and then during the night, while their enemy slept, all the troops came out and attacked the city. So it was supposedly a gift, but yet there was malicious intent with it, and there were attackers inside, and that's really what it is in terms of malware. Basically, it looks like an innocent piece of software or a useful program, but it's got attack tools, malware, malicious scripts, and so forth hidden in it. Now, Trojans are basically designed to relay commands or data to and from an attacker, from their PC or network, if you will. They can also be used to execute any attacks on other machines and on the victim machine that it resides on, as well as steal data. Now, Trojans use hidden or what's called covert channels to get information and commands. So you may not see this very easily. You may be seeing traffic over a port that should be open, like port 80, for example, or port 135, but it's actually Trojan traffic. So it's very hard to detect sometimes. Trojans are basically designed to be very stealthy and almost undetectable. Now, what Trojans are designed to do really is get an attacker on the box. In an earlier chapter, we talked about system hacking, and one of the big problems is actually getting your tools on the box or getting malware or something on the box that you can use to hack the box. Okay? That's where Trojans come in. They're basically designed to convey an attacker's foothold into a system, and basically they do this through the innocent program that is downloaded to the machine, emailed to an unsuspecting user, or pretty much otherwise transferred somehow or another to the victim's box. Now, what happens is this Trojan is inserted into a program in what's called a wrapper utility, and we'll talk about those a little bit later. But it's basically just a utility that puts a Trojan into a normal program. Now, this wrapper utility also programs this Trojan, the attacker programs it, to take specific actions, to use specific network ports and protocols, to install itself in a particular place, to go stealthy, to change the configuration, if you will, so that it can't be detected. Now, these Trojans may change their host program's file size or attributes just slightly, almost so they're not detectable. If you compared the before and after from a program, you might see a small size increase, for example. Now, Trojans, by and large, are detectable by antivirus software, but not always. Sometimes, even on a piece of known malware with a known antivirus signature, there are programs that will bit flip, change a couple of ones or zeros so that it will fool the antivirus signature and it can't be detected. Another way to fool antiviruses is actually to encrypt the malware as it's put into the program. Encrypted software, encrypted programs, and code cannot be read by antivirus software. So you may encrypt the malware so it can't be detected, or do the bit flipping to get around the signature problem. Now, if you've been attacked by a Trojan, there are a couple of things you might want to look for. Signs of a Trojan attack include increased activity by your network card or your hard disk. Maybe your hard disk is thrashing like crazy because it's going through files, or transferring files off the box. The network card may be using up a lot of network bandwidth because it may be executing an attack or carrying out commands from the attacker. Programs that open and close by themselves, sometimes for just an instant. Things that happen on the system that you don't understand, like the mouse pointer moving by itself or the CD-ROM tray opening and closing. Those could be signs of an attack. Any kind of strange configuration changes, desktop colors, themes, may be one thing that's obvious, but a lot of these configuration changes wouldn't be noticeable to you, to an ordinary user. Things like encryption being turned off or SMB signing turned off, for example, something like that. You also may see unauthorized account changes, like user accounts that weren't there before, or even your password policy has been changed. Maybe some accounts have blank passwords now. Another thing you might see are pop-ups, messages, and unexpected browser sessions that are opened and closed, sometimes very quickly. That could be a sign that the Trojan is communicating across the network or the internet. Some of the infection methods that a Trojan may have include phishing attacks, social engineering, obviously we've talked about, getting someone to load a USB stick. One popular social engineering attack is the use of road apples. That's basically where you drop a USB stick in a parking lot and someone picks it up and says, "Hey, somebody lost a USB stick. I wonder what's on it." So they put it in their computer without virus scanning it. Drive-by web attacks may mean that you go to a particular website and before you can do anything, you've downloaded some malware. We've all seen pop-ups. We've seen these fake virus alerts that tells you that your system has been infected and you must click on the button to disinfect it, and that's how you'll get the Trojan. Email obviously is another avenue. Now, we've already talked about some of the uses for these Trojans, including keystroke logging, capturing the screen, and basically all these things we've talked about is what any kind of malware could do, but Trojans in particular are bad about these things. And we'll discuss some more uses of these as we go into the next session and discuss a little bit more about how Trojans are put together and how they're used. Continuing our discussion of Trojans, let's talk about some of the uses of Trojans and the process for getting one built and put on a machine. Now, as you know, Trojans typically listen on TCP or UDP ports, so they do listen on the network. So one thing you might check when you're looking at your system is to see what particular ports your system is listening on and trace those back to processes and see if there's any that you can't identify. Although sometimes it's difficult to trace a Trojan just by TCP and UDP port alone because it may use a popular port that your system should be using. Now, Trojans aren't always active. They may be silent until activated. Now, typically there is some malware running there, but they may not do their destructive business until the right time. And this may require a command from the attacker. Now, a Trojan may have a very specific purpose, like a botnet, or be a very general purpose Trojan, just designed to mess with your system, to destroy data, log keystrokes, and so forth. Sometimes Trojans are used as backdoors into a system after an attacker has successfully hacked it. So they've hacked the system, they've gone into it, they've got privileges, they've elevated them, they've stole data. They may leave a Trojan also just in case everything else is discovered and their primary way of getting into the system is cut off. They may leave another Trojan resident in the system somewhere that they can use to get back in. Now, also Trojans are used very often to install other kinds of malware like rootkits, viruses, botnets, and so forth. Once again, a Trojan is an entryway into your system. It's the way of getting the foothold into the system. So it's not unusual to see a Trojan used to put other pieces of malware on the system, like rootkits, for example. Now, let's talk about the process of creating a Trojan. A Trojan by itself is a piece of malware. And by itself, it probably wouldn't be able to function or do anything on your system unless acted on, unless the user double clicks it or it's executed somehow. So what happens is Trojans are embedded into actual executables, innocent looking applications, useful applications, games, whatever. There was a popular game a few years ago, way back in the day, called Whack-A-Mole, and it was a cute little Windows game, but it also contained a known Trojan. And what happens is hackers will put these into these cute little programs using a wrapper program. And this wrapper program basically combines this malicious code with the program itself and then allows you to configure it. The Trojan program is configured however the attacker wants. The attacker configures the port it's going to listen on, the actions it's going to take, the IP address it needs to phone home to, and so forth. Then the big problem that has to be solved is the Trojan somehow has to get on the computer. We've talked about the different methods that could happen. So the Trojan either is placed on the computer by the user, an unsuspecting user, or some other means. Maybe it's downloaded automatically from the web. Maybe it's on an infected USB stick. However it gets there, once it gets there, the Trojan application is loaded on a computer. Sometimes the user double clicks on it and runs it. And when that happens, something called a dropper activates the Trojan and installs it. That's basically the installation program for the malware itself. Now, once it's installed, whatever malicious payload is contained in that Trojan, whatever set of actions it's supposed to do, or malicious code it's supposed to write to the system, that code is executed and it's installed. Once that happens, the Trojan can do whatever it wants. It can call home, it can be remotely controlled, it can start keystroke logging and reporting those keystrokes back, whatever its intended purpose is. Now, there are some general types of Trojans that we see, and this list is by no means conclusive. You could come up with any good reason to have a Trojan and create a Trojan just for that. General purpose Trojans, if you've ever heard of Backorifice or NetBus, those are two popular general purpose Trojans that we saw a long time ago. They can do a little bit of everything. We saw network service Trojans like FTP Trojans and Telnet Trojans that are basically designed to open up an FTP port and send data through it. So you might see port 21 open up on a computer that shouldn't be. Remote desktop Trojans allow a hacker to take control of a particular system through remote desktop, through VNC, for example, or RDP. You might see keyloggers that are Trojans, and obviously that's a very popular kind because it's used to intercept and get credentials and send them to an attacker. Email Trojans obviously can affect several things. They can cause random emails like spam to be sent, and that's what one purpose of a Trojan is to send uncontrolled email. Another purpose might be to propagate itself through email. Document Trojans are basically embedded programs in a document. The user would get it, open up the document, and when they do, the Trojan is executed. There are also web defacement Trojans whose sole purpose is to basically change HTML code and other active code on a website and possibly even deface the website itself, change the appearance, change the colors, font, and so forth. Botnet Trojans pretty much speaks for itself. A botnet basically is a network of bots that are pieces of malware that control and attack other systems. Proxies. A proxy Trojan is used basically to get another machine, like your victim's machine, to wage the attack or to download attack tools or to store illegal content, for example. Now, some of the Trojan tools that are out there, and there are a ton of them, and we can't possibly cover every single one of them in this course, by the way, but there's a lot of them out there. Some of these are older tools, but still very effective, especially if you can bit flip them a little bit or encrypt them such that antivirus will not pick them up. In fact, there's one tool, NetBus, and a lot of antiviruses don't even look for it anymore because it's that old. But it's been altered several times, and it's very easy to change so it can fool an antivirus. But Backorifice and NetBus are very popular Trojans. Netcad is the Swiss Army knife of hacker tools. You've probably heard that before. Cryptomatic is a wrapper tool. HTTP Rat is another good Trojan. Flame is a framework itself that we've seen in the news over the past couple of years very recently. So there's all kinds of Trojan tools out there, and we're going to demonstrate a couple of these in the next session. I'm in my Windows 7 VM, and I've actually started Cryptomatic, which is a Trojan wrapper or construction program. I actually get a user agreement here, basically. We don't need to see that anymore. And I agree to it, and then we get the main box here. And just to kind of give you a tour of this, here's the icon for the Trojan you're going to build. You can find another icon, and probably a good idea if you're going to do this for real. So you can select an icon. File binder is very important. This is the file you're going to actually bind to it. And this could be a file that you've run across somewhere, or it could be a system file. And you could add the file here. I'm going just to do something innocuous. I'm going to use a file from Windows, actually. Let's go into Windows here, and I'm going to scroll down a little bit and find the right command. Remember, old Windows write, very simple processor. So it lets me decide that I want to add the new file, what kind of memory execution, injection, extraction, and other parameters. And what kind of spread settings do I want to have on this? I think I want a USB spread, so I'm going to add the file, and that's it right there. And message box, do I want to send a message box to the user? And if I do, I can just select these parameters. I'm going to select the X here and put warning, and then you've been hacked. And we can also add buttons to the message box. We can say okay, yes, no, retry, cancel, whatever we want. And let's test the message here. And that's what we're going to get. Warning, you've been hacked. So spread settings here. And you can actually set the file name and other parameters. And you have some file names in here that it has, and you can change these. But it has things like Skype, LimeWire, service host, and so forth. And you'll notice a lot of Trojans bury themselves in things like service hosts, so you'll see multiple versions of that running on Windows sometimes. And some of those are legitimate because service host is just a wrapper for other services, but in some cases a Trojan could be hiding in there. If we look at the Install Plugins tab, there's different plugins here, and these are malicious payloads basically. And I selected the USB spread because I want this to spread via USB device. Some other settings we have here: compression settings, resource settings, and some of these are more complex settings, installation settings, folder names, and so forth, where you might want to install it. You can also change startup settings. You can change the HKLM registry key, HKCU startup registry key, and so forth. I'm not going to change any of those right now. And then you have the builder itself. And this is where you actually select the file name that you want to build and create it. I'm just going to call it VTC. And we can select the file extensions that we want. I'm going to go along with an exe file here, but I could choose like a screensaver SCR file or a COM file or a BAT or even a PIF, and some of those are older MS-DOS executable type of command extensions. So let's go ahead and stick with the exe, and let's create the server here. And it's going to ask me where I want to put this. So I'm going to go up a little bit and go into users, and I'll go into my profile here, and I'm just going to call it VTC and save. And there it goes. It's creating the file. Now I have a file called vtc.exe that's in my users Bobby directory, and that's our Trojan there. So we have several options we could do after that. We could get it to the individual's computer somehow and have them execute it. We could also further wrap it if we wanted to, and there's some other complex things we could do to get this file over there and have it do some damage. We have an About tab here, and you can also order a professional version. So that's Cryptomatic. So if we want to, let's go into that home directory there, and let's look in the documents here. Actually, let's go into users, Bobby, and that's where we see it. Now let's execute it. Let's see what we get. An application error, and it could be in the way it was built or the parameters that it was used to build with it. It could be that it's running on Windows 7 also. This is a little bit of an older builder, so no matter, we'd have to play with it a little bit to get it doing what we want it to do. But it's basically just a demo of how to use Cryptomatic. And again, there's some more complex settings that would probably be of use to you to study and try to play with and figure it out. But most of the Trojan wrappers that are out there work very similarly. Some offer different options, but they pretty much work the same way. So that was Cryptomatic, a demonstration of a Trojan wrapper. The next type of malware we'll discuss is the virus, and it's probably the most popular kind of malware out there, at least as far as the general public goes. Now, we've talked about Trojans and what they can do, and Trojans are actually very specific use tools that a hacker can use. A virus is also a hacker tool, but it has different effects and uses. Now, viruses are a category of malware that can have certain characteristics on a system and affect the system certain ways. Viruses can cause millions and millions of dollars of damage to companies every year, and to a particular company, after one attack, it can even be in the millions of dollars. And typically this value, this loss of money rather, is in terms of possible data loss, if they've had a data loss because of a virus, or manpower and labor hours to contain and clean up after an attack. This doesn't even mention the damage to a company's reputation or possibly liability, like in a criminal proceeding or a civil case that they may incur after a virus attack. Now, viruses are spread through several different ways, and pretty much most of them are preventable because most of them are through human interaction. People actually are necessary, and their actions are necessary to cause the spread of a virus. So that means that most of these actions are probably preventable. And hackers take advantage of several human failings because they know that humans are going to spread viruses. Now, what can a virus do to your system? Well, a lot of the infection systems are similar to other types of malware like Trojans and worms, which we'll discuss later. So you'll see things like system slowdowns, data loss, and eventually the virus will spread to other machines. Now, hackers use viruses to infect machines, to destroy data, to slow them down, to cause denial of service attacks, and so forth. So how do viruses infect hosts? Well, again, it's almost exclusively through human interaction. They can infect a host through email attachments, and that obviously means someone clicking on an email attachment or downloading it that's infected, someone using infected media on their host, like a USB stick, an SD card, or a CD. Obviously, we don't see infected floppies much anymore because most machines don't come with floppy disks. Installing pirated or illegal software is one major way. A lot of people will download free, supposedly, software, and the price they really pay is it may be infected with a virus. And they typically do this to avoid paying licensing fees for this software. Let's say you could download a pirated version of Microsoft Office. Well, you may get Microsoft Office and a lot of viruses to go with it because some of the sites you may download it from, some examples come to mind like Pirate Bay, for example. That was a popular file sharing illegal program site a few years ago. And these sites may have software that's been infected by viruses. So when you download a free version of Microsoft Office that you didn't pay for and you don't have to have a license for, you also may be downloading viruses. Also, installing hacker tools. A lot of security folks, and even unfortunately normal users, don't take the proper precautions when they're installing hacker tools. And a lot of hacker tools, in the first place, are viruses by themselves. A lot of antivirus software will pick up hacker tools as viruses. And in the second place, they install them on machines they shouldn't. They install them on machines that they're also using for work or for other things. They should install hacker tools, obviously, on machines that are solely for penetration testing purposes or in a laboratory that's not connected to a production network. We also have phishing attacks, obviously. User clicks on a link, goes to a site, virus gets downloaded. And even going to a website for just a moment that's been affected is what's called a drive-by web attack. You can get a piece of malware in the form of a virus downloaded. There's also malicious mobile code, speaking of websites, that can be downloaded to a machine also that's not configured properly. The key thing about viruses that you really need to know is viruses require interaction to spread. They don't self-execute. Someone has to double-click on something or download something and get it installed. Viruses by themselves are inert. They require some kind of interaction or action in order to spread the infection. They also can't travel from host to host over the network. They have to travel on a media or in a file. They attach themselves to a file and they travel that way. Someone has to email the file or put it in a file share where other people download it and so forth. It does not replicate itself, unlike worms. Now, there's some different targets that viruses typically go after, and these are just common. There's several more out there, but these are some common virus targets. You have boot sector viruses, which obviously infect the boot sector of a computer so that when it boots up, the virus comes into play, and frequently that's not easy to detect. Some antivirus software will detect it, but not always. You have executable files, and this is basically because a virus has to attach itself to an executable file in order to spread, in order to infect the host. So the file is executed and it gets spread and infected. There's multi-partite viruses that infect different files and then later infect the boot sector. So it's kind of a multi-purpose virus. You also have application-style viruses in the form of macroviruses, which are really nothing more than a set of macros, useful commands that someone has made to do something malicious. And I obviously mentioned mobile code, Java applets and so forth that have malicious code in them. Now, there's several different types of viruses that we'll discuss as well. There's polymorphic, which can change itself to avoid detection by antiviruses. Then there's metamorphic, and metamorphic can change itself temporarily to one state and then back to its original state to avoid detection. You also have encryption viruses, and obviously those are encrypted so they can't be picked up by antivirus. We mentioned the boot sector virus already. The cavity virus infects the free space in a file, so it actually doesn't change the file size. It just lives in the free space in a file. Then you have a sparse infector, and the sparse infector may infect different parts of a file, like every 5th bit or every 10th bit or whatever, not the entire file. Then you have companion viruses, and companion viruses basically cause the directory or the operating system to find another file in the directory that's named similarly, but it is the virus. So it doesn't go to the file it's supposed to, it goes to another file, which is typically the virus. Now, a file extension virus can also cause issues because that type of virus typically has a different file extension. You may have something called work.txt, and that's inert. That's a safe file. Then you may have work.txt.vbs, which may be a virus, and it basically uses an executable file extension. So those are some viruses out there that we see, some different types of viruses. Okay, I'm looking at our Windows 7 virtual machine, and I've loaded Terabit Virus Maker. And this is a very simplistic program. And one thing I want to remind you of, I think I've mentioned it previously in another session, but as far as hacker tools go, you may want to load them on a box. In most cases, you'll have to load them on a box that does not have antivirus loaded on it, because obviously antivirus software will pick up these tools as hacker tools and isolate them, make it so you can't use them. They'll be isolated, they'll be eradicated, cleaned, whatever. So you want to put these on a box that you don't care if it gets infected or contaminated. One thing I will mention is that a lot of penetration testers, myself included, if you're going to use Windows hacker tools, use them on XP. It's a little bit better because Windows 7 and Windows 8 both, and even Windows Vista to a degree, all have enhanced security features that make some of these hacker tools inert on your box. They don't do anything because the box won't let them, because Windows 7 and 8 are more secure. So you want to run these on XP if you possibly can. I'm running this on Windows 7, not a big deal for it, but just to let you know that that's a consideration sometimes. We talked about tools around the first of the course, and we talked about the value of Windows versus Linux tools, and I will tell you that there are some good Windows tools out there, but you probably are going to be better off using them on a Windows XP box than a Windows 7 box, for the most part. So if I were you, I would create a Windows 7 standalone laptop for most things, for your reports, your email, and so forth, and I would not run your hacker tools on that. On another laptop or even a virtual machine, I would install Windows XP and install all the Windows hacker tools that you want on it, and obviously with no antivirus on there. So just took a little time to tell you that, because in some cases you can have difficulty installing some of these tools on Windows 7 and Windows 8. So getting back to Terabit Virus Maker here, there's some things you can make this do, and some of these are fairly innocuous. You can change the keyboard and mouse around a little bit, remap the keys and so forth. Avoid opening calculator, copy and move window. This prevents them from doing this. Avoid opening GP edit. Avoid opening media player. Different things. Adding Windows users. Cleaning off the clipboard so they can't save anything to the clipboard. Logging them off automatically. Deleting all the files in my documents. So some cute little things, obviously. Disable CMD, disable regedit. So some cute little things that would probably, at the very minimum, irritate a user. But when you start checking things like format all hard drives, well, that's probably going to do more than irritation. So this Terabit Virus Maker can do some interesting things. And you can even create binders that it would execute at the first run here, fake error messages, run custom commands on the box, and you can even add fake kilobytes to the virus to pad it out so that its size looks different than what it should. And in some cases, this might be to avoid antivirus detection. The file name after install, the file icon Word, the file name virus.exe. And you could create the virus by clicking the box, and it'll go through its little deal and sit here and see what it does here for a second. That's the other thing too, is loading it on a Windows 7 box can severely degrade your performance with some of these tools because they have to navigate around all the security features and some of the more complex operating system features. A lot of these tools were designed to run on something like Windows XP, not necessarily Windows 7 and 8, because a lot of these tools are a little bit older. And we can select the file path. I'm just going to put my documents here. We're going to say OK to that, and it's created my virus successfully. We can go and take a look at that if we want. Let's open up my documents and see what it stuck in there. There we go. And there is our virus right there. And I'm not going to execute it or anything like that, but so we've seen how to create a virus with Terabit Virus Maker, a really easy program to use. And we didn't give it a lot of complicated options, so it probably wouldn't do us very much harm, but it can do some damage. So that's just a demonstration of a virus maker. And again, there are tons of them out there, most of them probably for Windows. So that's just one example of one program out of the thousands that you can use to create a virus. The next type of malware we're going to discuss is the worm. Now, come on, you didn't really think you were going to get out of a discussion on worms without seeing a cheesy picture of a worm on a keyboard. Worms are the third type of malware that we'll discuss, and they can be very similar to Trojans and viruses, but they have some unique characteristics. Worms typically carry malicious payloads that can infect hosts and turn them into zombies. By zombie machines, we're talking about machines that have the capability to attack other machines. And normally this might be from machine to machine, but they can also become members of botnets. And these botnets, when combined and grouped together and controlled centrally, can attack large numbers of computers, entire networks, and can bring enterprise-level networks down. So worms can carry the payloads that infect hosts to do that. One popular modern example of a worm that we've probably all heard about was the infamous Stuxnet. And Stuxnet was a worm that attacked industrial control systems. Now, there was some speculation as to who invented Stuxnet, and it's never actually been officially proven who did, but most people suspect it was a nation-state, a government of some kind. Now, Stuxnet has been out for a while, and it's been analyzed, and it's a classic example of a worm that was used to take advantage of some sincere weaknesses in the target system. Worms aren't like viruses and Trojans in many different ways. First of all, worms self-replicate through the network. They don't need a file as a carrier like a virus does. A virus has to be stuck in a file and sent via email or through a USB stick or network share or something like that. A user actually has to execute that file and get it manually from host to host. Worms don't need that. Worms self-replicate through the network. They can use chat, they can use IRC, they can use several different network programs and services to spread. The other thing about worms is they generally don't alter programs. Viruses do. Viruses can change program characteristics like file size and so forth, but worms generally don't do that. Worms are concerned with spreading and releasing their payload. Now, worms can actually be very easy to remove from a single host, but not from a large network. Once you get it removed from a host, it typically will spread back to that host unless you pull the plug on it and take it off the network. To clean a worm off of a network is a very large endeavor. That's why in some ways, from a network perspective, worms are typically more destructive than viruses. A virus may destroy data on an entire host, and that's very destructive. Or it may spread to other hosts through manual means and get a lot of hosts. But worms spread by themselves, and that's the problem. They can infect a large number of hosts over a large network, and it's very hard to kill. As soon as you clean off one host, it affects another one, and eventually may come back to the original host you cleaned. Worms are used to create botnets, and those are used to conduct distributed denial of service attacks on networks and other hosts. They require much more effort to remove from the network, and in fact, in some cases may require wiping the entire network to do so. In other words, you may have to wipe and rebuild your Exchange server, your domain controllers, your file servers, because it may be hard to get rid of because it keeps coming back. As soon as you think you've gotten rid of it, you plug it up in the network and it comes back. So it may require a rebuild of the entire network infrastructure. Now, some examples of worms that are out there include some that are a little bit older. In fact, the first worm was the Morris worm. Robert Morris invented the first worm back in 1988, and coincidentally for his actions, he was also the first person convicted under the 1986 Computer Fraud and Abuse Act. So he got some community service out of that deal, and now he's a tenured professor and an entrepreneur. However, he created the first worm called the Morris worm to demonstrate security vulnerabilities on the internet, which wasn't very big at the time, but it cost him some jail time. Now, some other popular worms include the I Love You worm, which is really called a virus, but it was a worm, the MyDoom worm, Win32 Configure, and there are other examples out there. SQL Slammer was a big one that attacked Microsoft SQL servers. Stuxnet, obviously, we mentioned. Now, since we've been talking about malware, and worms in particular, what are some things we can do to prevent worms? Well, we can definitely install antivirus and anti-malware, and they will pretty much pick up most worms and viruses, not always. And we've talked about ways that you can prevent a piece of malware from being detected by bit flipping or encryption. But as a user or as a network administrator, you can make sure all media gets scanned, because the infection starts somewhere. It can start with media or start with an email attachment, so you should scan email attachments as well. Use intrusion detection systems and other security devices. One thing about worms is when they start to propagate, they can be noisy. So when you start seeing a lot of traffic, weird traffic, moving from system to system across the network, that might be an indication that you're under attack from a worm. So an IDS or even a sniffer might tell you that. So sniff through your network traffic and look for unusual signs that may indicate an infection. If you have an infection or think you do, unplug the infected host from the network, especially before it gets time to spread. So if you unplug that host, you can clean that host hopefully and contain it. Or if you wind up cleaning other hosts on the network, at least that one's not plugged in to get reinfected. You want to make sure you clean every single one of them and it's all gone before you plug anything back in. And the final thing you should do, obviously the most important thing you should do, is educate users. And this is because most users are, unfortunately, the reasons that a lot of malware gets on systems, and hackers rely on that. They rely on users not following procedures, not thinking about things before they click on them, and so forth. So from a security perspective, those are some countermeasures. From a hacker perspective, though, we'll take a look in the next session at some popular worm programs. Okay, we're in the control panel of the Internet Worm Maker Thing version 4. And basically what this will do for us is create, or help create, a worm that will replicate itself and go all over the place and do some malicious things. Basically what you see is what you get. This is actually not too complicated to use. Most of it's pretty self-explanatory, but we'll go over some of the options. First we can hit the About Me, and you can figure out that's who invented this. And obviously he's not giving up too much information about himself there. Kind of cute. Little message there is. Now, we can put in here a worm name, and I'm just going to type in VTC. And author is Bobby. And version, we can call it version 1. And message, this is only a test. And we can include a copyright notice if we wanted to, like a worm's copyrighted, I guess. Compiled exe support. Then we have some spreading options here. On startup, do we want to hit the global registry startup or the local registry startup? When log on shell hook, start as a service, or which language to start up with? Now, as far as payloads go, we can activate the payload on a certain date. And we could also randomly activate the payload, so it just happens whenever. We could also say the chance of activating payload is 1 in, say, I don't know, 11. So every 11th or 12th time the payload would activate, possibly. Hide all the drives, disable the task manager, disable the keyboard and mouse, flash up a message box, possibly, an icon to go with it. And you could select critical icons for the message box, possibly, and we'll type in like warning and message, you have been hacked. We could disable the registry editor, disable Explorer. We could change the registered owner of the box and the registered organization. We can change the home page to a URL that we want. We can do other things like disable Windows security, disable Norton security. So you can actually disable and affect antiviruses with this worm creator. We can disable macro security, disable the run command, shutdown, log off, Windows update, all kinds of things here, all kinds of fun things. We can change Internet Explorer's title bar. We can change the Windows Media Player text, open CD drives, lock the workstation. We can even download a file, specify the URL that we're downloading from, save it as a particular file, and then execute it. Pretty cool stuff, huh? We can print messages. We can have some fun with Outlook, mute the speakers, delete files, delete folders, change the wallpaper. Again, all kinds of cool stuff, and some of this can be just fun, but some of it can be very destructive. And a lot of these options are designed to prevent a user from A, detecting the worm exists, and B, stopping it once it executes and starts. And really, it can be used to take control away from them of their machine, so that we may use another type of malware like a Trojan to assume control and turn it into a botnet, or execute a payload in this worm that will make it a member of a botnet. So we can change the time and date if we want. We can loop sounds, hide the desktop, disable malware remove, disable Windows file protection, corrupt the antivirus. Again, all kinds of interesting things. And hackers actually do these things to create these files to do this. Infection options, BAT, VBS, or VBE files. We can even make a blue screen of death occur. We click the plugins box. There's no plugins loaded. We could load one, but would have to have one on the box. Here's a sample plugin we can use. So we can load it, say OK, and write custom code. And we could put the custom code in here as well. So that's the Internet Worm Maker thing version 4. And again, very simplistic. And there are other worm makers, other programs that will do this as well. And it's curious that most of the cool programs like this that create Trojans and worms and viruses are Windows-based programs. You can do this in Linux, but it probably requires writing some code. And there are some tools out there for Linux that probably do exist for this. But keep in mind that a lot of the viruses, worms, and Trojans that are designed in fact for Windows. You don't see a lot of people creating malware for Linux. That's not to say it doesn't exist, although Linux users will tell you different. There is some malicious scripts out there for Linux and some malicious compiled code. However, it's very rare. So it only makes sense that most of these creators, these programs that create viruses, worms, and Trojans would be Windows-based programs, since they are creating mostly stuff to infect Windows with. So interesting stuff. But that's an example of a worm maker. Again, there's other examples out there, so this is a good example of one.